Percent concentration, what is it and how do we calculate it? There are many ways to express solution concentration. There are qualitative ways or non-numerical where we say the solution is unsaturated, that is, it does not hold as much solute as it can possibly hold. It could be saturated, meaning it holds as much solute as it could possibly hold, or supersaturated, indicating it holds more than it can normally hold at a particular temperature or set of conditions. Unsaturated we could also describe as dilute, meaning a small amount of solute compared to the amount of solvent, or concentrated, indicating there's a lot of the solute compared to the amount of solvent. Today we're going to focus on one of the quantitative methods, and that is percent concentration, which either can be volume per volume or mass per volume. Volume per volume if we're talking about two miscible liquids, two liquids which will dissolve in each other, or mass per volume if we're talking about a soluble solid that will dissolve in water or some other solvent. We'll start with percent concentration volume per volume, and the equation you see here is the percent concentration volume per volume is the volume of the solute divided by the volume of the solution times 100%. Note, as in all percent problems, it's one part divided by the total. The solute is the one part, the solution is the total that consists of both of the solute and solvent added together, and that is something to pay attention to here. Example 1, what is the percent composition of a solution made by dissolving 100 mils of ethanol, so that is the solute, in 400 mils of solution? Again, note here, you're given the volume of the solution, which includes both solute and solvent. So the percent concentration is the volume of the solute, the 100 milliliters, divided by the volume of solution, the 400 milliliters, times 100%, or 25%. Watch this next problem carefully. What is the percent composition of a solution made by dissolving 100 mils of ethanol, so that is the solute, in 400 mils of water? Now that is not the solution, that is just the solvent. The solution is the sum of the solute and the solvent. So here we do not want to divide 100 by 400, but 100 by 500, which is the solute, the 100 mils of ethanol, and the solvent, the 400 mils of water, added together. So that would give us a 20% volume per volume concentration. Mass per volume is very similar, although we don't have to worry about the additive of volumes. And so here we've got the equation as percent concentration mass per volume is the mass of the solute divided by the volume of the solution times 100%. So note this problem, we've got really two parts. What is the percent mass per volume concentration of caffeine and of sucrose? We want to figure it out for caffeine and for sucrose made by dissolving 0.015 grams of caffeine, 20 grams of sucrose, and enough water to form 473 milliliters of solution. Again, the solution is both solute and solvent added together. So pretty simple here. It's just the mass of the caffeine divided by the volume of solution times 100% to get 3.2 times 10 to minus third percent. Note we include units here to indicate what mass we're talking about, what volume we're talking about. If you were to change units to something else, say grams per liter, then our percent concentration would change dramatically. And the percent sucrose, simply the mass of the sucrose divided by the volume of the solution times 100%, giving us 4.23%. And again, indicating units, these are in units of grams per milliliter.